Mr. White.
Mr. Rops.
Okay, we're going to do a podcast. This podcast is on standard deviation, so we're going to go back to the slide we actually want. Do that one next. Here's standard deviation formula. Basically, a standard deviation is just a descriptor for the spread. The number itself doesn't really mean anything other than just how big the spread is, right?
Right. And one of the things that I've told kids in the past, it's not exactly, but it's kind of like the average distance away from the mean.
Great. I was going to say the same thing. A teacher once told me that it's basically taking all the numbers, and if you calculate the average distance from the mean, it's sort of like the standard deviation. It's almost like that. You see that you take the difference, you square it. If it was like that, that would be a little bit closer, but it's not. So, but it does help to think of it maybe sort of like an average distance from the mean. What we're going to do is we're going to do this whole, we're going to develop the standard deviation from scratch using our calculator. And here's our formula. The reason we're doing this is I think it's just good calculator work and just to see what's going on here. So we've got a list of numbers here.
So they should probably be practicing and doing this as well as we go through it.
Yeah, get your calculator out. So once you look at my list of numbers here, 1, 5, 7, 13, 12, 8, 0, and I think there's a 1 stuck there. So there's our numbers. Okay, so let's go to the main screen. We're going to push second stat, go over to math, and we're going to calculate the mean of L1. Okay, and we're going to store that. Well, let's just calculate it, right?
Okay.
There's our mean. And then we're going to, so that's 5.875, I think we can remember that. So go to stat, edit. We're going to go up to L2 here, and we're going to go second stat ops down to sequence. Maybe Mr. Ops has a faster way to do this, but I'm not sure.
I'm not sure either. I'm going to see what you do.
Okay, let's just push number 5 here. Sequence. Okay, it's your function. What was our mean again?
5.875.
0.875, comma, our variable, common, our start, I believe, comma, our finish. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. Hopefully this works. There we go. So it puts. All right, we have a very boring function. It's just always the same number. So it's the function, comma, the variable, comma, the start, comma, the finish. Okay, and then what we want to do, we go back to our formula. It says take our values minus our mean. This symbol right here means the mean of the population. So we're going to go up to, you have to, anytime you want to do something, you got to highlight the list, unless you're actually just putting in a single value. So we're going to go L1, and then what, Mr. Ops?
Minus L2.
Minus L2.
We have to put that in parentheses and square it all at once.
Let's do it all at once. So we'll insert a parentheses, and square it. So we're going to subtract, and then we square all the values. See right there?
Yep, which is what the top of the thing says to do.
Good. So you see that these are all positive, because 1 minus 5.8 is negative, 5 minus that's negative, this is positive, but we end up squaring all of them, so they turn all positive. Okay, we can get out of this main screen. It says to now add up all of these values. So we're going to go second stat sum.
Number 5.
Sum of L3.
3 we're in, yes.
Okay, that's this. And then we want to divide by 8.
Yes,
right?
because that's how many numbers we have.
Divide by 8 is this, and then take the square root of our answer, which is this. So our standard deviation, and we write this with a sigma. Sigma is 4.7. Okay, so now let's do that all that work in one step. Okay, how do I do that, Mr. Ops?
Oh, well, you have your values in L1, so if we just go stat, toggle to calculate, one variable stats, it's already in L1, it's the default L1.
Just do it anyways.
Yep, good practice. Enter.
Here we go. We see 4.70 right there. That's the one we want. So now this brings up a good point, something that needs to be talked about. This is your standard deviation of the numbers you actually took right here. This one, however, this one is what, Mr. Robs?
That is if it was a sample.
This is a sample.
Population.
So if you have a sample and you're estimating the standard deviation of an entire population, a bigger population than your sample. This one is if you have the population, the entire thing. Slightly different. However, this one you see is an S. This one is a sigma. Your formula booklet is an S. Okay, there's your formula right there. Formula is an S. That's wrong. You need to use the sigma. Okay, that's for the IBSL only.
So will they ever need to use that S in the calculator?
As far as I'm aware, they will not.
All right.
Okay, and another thing you might find on your own is if you go to second stat, go over to op math, and you see standard deviation there, number 7 of L1, 5.02, 5.02. You cannot use this one. It's wrong.
Okay.
The only way you need to be doing it is with the stat, calc, single variable, and enter.
So the only way they're going to get it right is if they do it by hand or if they use one variable stats.
Yes. There you go. Okay. So let's run on to one podcast one more question real quick. And so this is, let's get rid of some of these numbers.
Okay, so what we're going to just do is find the midway point of this one interval. So we can go 40.5, 42.5, 44.5, 46.5, 48.5, 50.5, and 52.5.
Okay, so that was a little boring.
Yep. And then the other side is 1, 1, 3, 7, 11, 5, 2. All right. Data entry, not much fun,
Okay.
but important.
So let's just do this very quickly. Stat, calc, single variable. L1 are the values. L2 is the frequency. You should know that by now. Enter. Which one do I take, Mr. Rops?
Oh, you take the sigma.
Sigma. So 2.657. There you go. There's your podcast. Have a good day.